All right, the general functions and locations and the position of the heart. So we're going to try and describe the general function of the cardiovascular system. We're going to differentiate between the three primary types of blood vessels. Note the three there. Describe the general structure and function of the heart. We want to then compare and contrast the pulmonary circulatory system and the systemic circulatory system. All right, so our general function, we already hopefully know that it is for transporting blood throughout the body, right? So this allows an exchange of oxygen and nutrients and carbon dioxide and all that good stuff between the capillary blood and the body cells. So perfusion is an important vocabulary term for us right there. So we want to go ahead and just highlight that or cover it up. And this just means the delivery of blood per time per gram of tissue. So an adequate amount of perfusion means that we have enough oxygen and nutrients getting to the cells to maintain their health, which of course is super vital. But this means that our body has to continually pump blood and go into those open and healthy vessels. So there's three types of blood vessels, right? So here's number one right here. Our arteries are going to carry blood away from the heart. Most of them are going to carry oxygenated blood. Our veins are going to be responsible for carrying blood back to the heart, and most of it's going to be deoxygenated. And then lastly, we have our capillaries there, where we see our gases being exchanged. So blood and air in the lungs, and then between blood and the body cells throughout the body. So we can see here, it's a pretty intense system with those capillary beds allowing for an exchange with the systemic cells of oxygen, carbon dioxide, nutrients, and waste. Okay, there are four chambers within the heart. We have our left atrium and our right atrium. These are the superior chambers that receive blood and then send it into the ventricles. So they are just holding places. Then the left ventricle and the right ventricle are the inferior chambers that are going to pump blood away from the heart, either to the pulmonary system or into the systemic system. So the left side, note, is going to have deoxygenated blood, while the right side is going to have deoxygenated blood. All right, so the major vessels, or the great vessels that are going to transport blood to and from the heart's chambers, are going to start off with our pulmonary trunk right here. And then we're going to see that that's transporting blood from the right ventricle into the pulmonary arteries, which then are going to go into the pulmonary system, which is, of course, the lungs. And then we have our aorta here, which is going to transport blood from the left ventricle into the whole rest of the body. Then we have our superior and inferior vena cava, and these are going to drain deoxygenated blood into the right atrium. And then our pulmonary veins are going to drain oxygenated blood into the left atrium before it goes into the left ventricle and through the aorta out to the rest of the body. So we can see that here we have our superior vena cava right up top, our inferior vena cava coming into our right atrium, then it's going to go into that right ventricle. It's going to continue on into the pulmonary trunk, which is going to split into the pulmonary arteries. Arteries are always carrying blood away, even if this time it is deoxygenated. So then it's going to come back in through the pulmonary veins into that left atrium, into the left ventricle, and then out through the aorta and to the rest of the body. Okay, so there's two sets of valves within that, because we do have four chambers or rooms, and then there are doors that go ahead and allow the blood to go through at certain times. So the first ones that we have are the atrioventricular valves, also known as the AV valve. So then we're going from the atrium into the ventricle, and that makes the valve. So we have the right AV valve, also known as the tricuspid valve, because there are three flaps there. And then your left AV valve, which is the bicuspid or mitral valve, again, that's going to have two of those flaps, hence why it's called bicuspid. And then we have our semilunar valves that are going to be between the ventricles and the arterial trunk. And so these allow blood to flow through the heart and then close to prevent backflow. So there won't be the blood going in the wrong direction. It'll always continue in the same direction. So we have the pulmonary semilunar valve, which is going to be between the right ventricle and the pulmonary trunk. And then the aortic semilunar valve, which is going to be between the left ventricle and the aorta. Which makes sense. Pulmonary trunk would have the semilunar valve, so pulmonary semilunar valve, and then the aorta would have the aortic semilunar valve. So we can just see those right there in our picture here. We have our right AV valve with those three flaps, and therefore that makes it the tricuspid valve. And then we have our bicuspid over here in the left ventricle, and then those semilunar valves. So right here, this one would be our pulmonary, and then the one right below that is going to be the aortic. All right, so with our circulation routes, we do have two different types here. So the very first one is going to be our pulmonary circulation. This is where we're taking our deoxygenated blood and taking it from the right side of the heart into the lungs to go ahead and pick up oxygen and release carbon dioxide. Note that the blood vessels are going to return to the left side of the heart in through the pulmonary veins. Veins are always carrying blood to the heart, arteries are carrying it away. Our next one that we have is going to be our systemic circulation, and this is going to take that oxygenated blood from the left side of the heart and take it to the rest of the body or the systemic cells. So this is going to be like our skin and our muscles, where it's going to exchange gases, nutrients, and waste, and then they're going to go ahead and return blood to the right side of the heart through the superior and inferior vena cava. So there's a basic pattern here. We start with our right side of the heart, goes to the lungs, left side of the heart goes to the systemic tissues, and then back to the right heart. So just notice that this is a closed loop, okay? And that's exactly what we're going to see here, right? We see that it's going to go ahead and start right here, and it's going to flow through into the lungs, into the left side, all the way through the system and back around, right? So it does contain in itself just one full loop there. And then this is just showing some different examples of the systemic versus the pulmonary circulation. And so then we just have a couple questions for our understanding. So what units are used in measurements of perfusion? Again, that was our milliliters per minute per gram. And then what different functions are served by the left and right sides of the heart, right? We said that the right side was going to be specifically for collecting deoxygenated blood, and it's going to send that into the pulmonary circulation. And then our left side is going to be specifically for taking that O2 or that oxygenated blood to the systemic circulation, so to the rest of the body. And then what are the functions of the three different blood vessels? We know that our arteries are going to be specifically for taking blood away from the heart. So we'll go ahead and put away here. And then our veins are going to be taking blood towards the heart. And then our capillaries are going to be responsible for the exchange of gases and nutrients and wastes.